Hi, it's 9:45 PM on Tuesday night and I'm in Melbourne. Decided to come to the Melbourne Hackerspace. Let's check it out. It's the new one. If you've seen my video last time, it's moved out of Andy's garage and ta-da, here it is. It is. Oh, and there's Andy. Straight up.
Welcome to the new Melbourne Hackerspace location. So
thank you very much.
It's about 4 or 5 times larger than the previous garage, so it'll still be busy, but not quite as squeezy.
Excellent. And about 110 square metres?
Yeah, about 110.
About thereabouts?
Yeah, so it was a garage. You can see from the lifting hoist that probably used to be like a car mechanic.
Right.
So that's handy for lifting engines out of cars. And we've got a little bit of room out the back for a bit of a quiet programming meeting area. So it's a wonderful space.
Got it.
Yeah.
Takes on a tour. What have we got? Look, just in the doorway here, we've got an ultrasound machine, as you do.
Yeah, well,
why not?
I guess we can use it for checking out what's inside. Yeah, 3D printing plastic to see how well formed it is, or cavities, or inside bits of metal. Of course, it's not going to work very well through air gaps, but so we'll see how that works.
Name tags.
Yes, quite a problem is we have so many people coming through. It's hard for everyone to know who everyone is. So, so we put name tags on and pigeonholes for trip hazards. So we try to be a little bit practical. Roughly speaking, on the left there's a lot of machinery, so lathes, 3D printers, a laser cutter, mills, those type of things. And on the right are sort of workbenches for people working different activities, be they woodworking, metalworking, electronics, and so on. So sort of,
Sure. There's a
Hey Dave.
Jonathan Oxer. Everyone knows John from Freetronics.
Well, maybe 2 or 3 people do.
2 or 3. Come on, all of my audience know.
The Amp Hour now, so I'm famous.
You've been on the Amp Hour. You are famous. Is what one of your goals in life was to be on the Amp
that's
Hour?
right, the bucket list. That thing's ticked off now.
Excellent. And your partner in crime,
Mark,
I believe, is working for Andy's company.
Yes.
LifeX, yes.
LifeX Bulb.
Yeah, we've been very fortunate to pick up Mark. He's obviously one of the best engineers you could possibly have working on your team. So
fantastic. And how's that project going?
Going well, I believe. The guys are in China. They're working at the factory to get a pre-production bulb done. So I've heard it's good news.
Excellent. All right, looking forward to it. So he's over there, and you're left holding the bag, huh?
Yeah, he'll be back in Australia in a couple of days.
Excellent. Good on you, John. And what have we got here? Oh, we've got a PCB etcher. Nice.
It's a little CNC mill.
A little CNC mill for PCBs. Yeah. What's the resolution on that?
Pretty fine. The finest resolution that we've been able to achieve is about 0.2 mils. So,
0.2 millimeters? Yep.
Yeah.
Okay.
Which isn't too bad.
That's all right. That's about 8 thou, I think.
Yeah.
That's about 8 thou. Width and space, so not too bad at all. And that's built from scratch by the looks of it, completely.
Oh, yeah, that's
using right.
That's an old Hackerspace project.
Okay.
Yeah, it's still a work in progress.
And what's this sucker here?
That's the controls.
Oh, that's the control for it.
This is the brain.
What's it using?
An ATmega 644P.
Right.
And then just various stepper motor controllers and switch motor power supply.
Good work. All right, what else have we got? We've got a lathe. Yep. Excellent.
So that was a warehouse that belonged to Mark Alexander's grandfather, and we saved it from being lost.
Very nice.
And what's great about this is we have a number of members who've got the old school trade skills, and then when the young lads come along, they basically close the circle. But, if you're doing things with robotics, so you need to be able to lathe metal, print things. So.
And this is the
Hack CNC.
The Hack CNC, which a lot of the guys here at the Hackerspace put together for the Linux conference.
Yes, this was used on the Monday for the Arduino Mini Conf.
Yep.
So the idea was to be able to show people how they with milling of MDF and some 3D printed parts you can see here, and an Arduino and stepper motor control. You can create a kit very simply. So the goal was to be able to build this in under 2 hours and to then put the software on. So John can tell you more about this because John was the lead designer.
I think you've pretty much covered most of it.
Right.
But
running one CNC.
Oh, okay.
Yep.
Right.
I'm not exactly sure what it's doing right now.
And you've just got a Sharpie in there at the moment, so it's just trying to...
You can use it for engraving.
Yeah, you can use it for anything you like.
Tattooing for brave. But about 34 people attended the mini conference and made this, and a few more people have got assembled kits. So
very nice.
We're very pleased that everyone was able to build these.
And Freetronics will be selling the controller, I believe.
That's right, yes.
Yep. Right.
So it's
Excellent.
it's a great little board. So it's got two-step motor controllers and a servo controller. The display has a Nintendo touchscreen for input.
Oh, okay.
And,
Right.
has an SD card as well. So it's a good little board. Arduino Leonardo.
Excellent project. I like it. Great work, guys. And we have a whole bunch of nerds on this table doing. Looks like they're taking apart their mobile phones, as you do.
As you do.
Hey guys, you're actually replacing the screen. Oh, who did that?
Me.
Excellent. Well done.
Thank you.
Yep. So you thought you just.
talent's all mine.
So these are obviously Raspberry.
Yep. And we've got some Raspberry Pis.
And we're very fortunate to have Alex.
Alex, who is the head software developer,
Seems to be described as a lead Linux software developer.
leading software developer of the Raspberry Pi, folks. He's all the way from England, from the old Dart. Yeah. So you work on that. It's an English thing, isn't it?
Yeah,
The
so
Raspberry Pi.
basically everybody is based in Cambridge almost, so there are 6 trustees, of which 4 or 5 of them are based around Cambridge.
Yep. And how's the project going? How many?
So it's shipped almost 1 million units now.
Yep,
And
so,
we've just
yeah.
announced the Model A has just become available for sale in Europe as well, which is a version.
What's the difference between that?
So that version has only 1 USB port rather than 2. It
Right.
has no Ethernet, and it has 256 rather than 512 megabytes of RAM.
Got it.
And exchange for that is $25 rather than $35.
Yep.
And for people who are working on projects embedding it, it's got substantially lower power usage.
Got it. Excellent. And how many software people working on that? Do you know?
Well, in terms of it's mostly in the community, so there's a few volunteers like
Right.
myself.
Yep.
We're starting to get paid employees at the foundation now, but it's roughly a few volunteers like myself who work very closely with the foundation, and then a whole host of other people around the world who contribute in varying amounts.
Excellent. What do you think of all the clones and stuff like that of the Pi? It's a good thing, right?
Yeah, absolutely.
Yeah.
I mean, the aim of the Raspberry Pi Foundation is to improve computing education. If somebody else comes along and they produce a product which which they can do it for the right price and is better in some way, that's fine. I think that we do have a massive community built around the Raspberry Pi.
Right.
That is very, very hard to replicate. Plus, a lot of the boards which have come out, we have very, very powerful GPU compared to a lot of the other boards which are coming out. Also, the ARM chip we have versus the Cortex A8, the floating point performance is actually pretty decent.
Excellent.
But it's all welcome.
Is there any more powerful ones in the works, or?
It's not the sort of thing we talk about.
Oh, check out the grin, folks. Check out the grin.
Everybody asks this question as if this is going to be the moment when something is announced. But look, we're focusing totally on improving, building out the platform we have right now.
Right.
So we can get an awful lot out of tweaking the software on it. So we've been have a whole bunch of contract work going on doing ARM optimizations for libraries like Pixman, rendering stuff. So hopefully people will be able to squeeze out more and more power out of the board. I mean, if you compare the original software release to what's out there now, you'll see quite a substantial difference in performance, and that'll continue as we move forward in time.
Got it.
Designing for manufacture at low cost.
That's tough.
Getting it onto it's a 6-layer PCB in the end, but all the optimizations to getting it manufactured as low cost as possible. There is lots of really detailed work there. But yeah, certainly it comes. I mean, one reason it's possible is, as you say, it's a very small number of components. So it's the Broadcom SoC. You've got the USB hub on Model B. Otherwise, it's basically all connectors, your capacitors, this and
Exactly.
so on.
It looks incredibly simple. But there's a lot of effort goes into design for manufacture and stuff like that. Terrific. So, what are you doing here? Why are you all the way from into Melbourne?
Well, I've been in Canberra last week for the LCA 2013 event.
Did you give a lecture there, did you?
Yes, I gave a talk. Gave a talk for Richmond, and so now I'm spending this week travelling around a little bit, taking advantage of being in Australia, visiting places like this. So I'm in Melbourne.
Is this your first time in Australia?
My first time in Australia, yeah.
Excellent.
Yeah, so I'm heading to Sydney tomorrow and then back home on Saturday.
Fantastic. Enjoy your stay.
Thank you.
Thanks, Alice. All right.
So every hackerspace needs a couple of 3D printers.
And yes, we have a MakerBot.
It's an
Ta-da!
original cupcake that's been highly modified. There's a heated bed. There's also a custom extruder, by John Bosch.
Oh, okay.
And
All
all the electronics have been ripped off the side and replaced with a ramp board.
Yep.
And there's a ramps board, and there's a completely rebuilt Z-axis. So it's not your normal cupcake.
Right.
It prints really well.
It prints really well, yep.
So the metal cruiser was built
Yes.
in this place. You'll notice it's got the same ramps board and the same extruder as the
Right.
cupcake. So
Oh, okay. So there's some commonality there. That makes it makes it useful. Yeah.
These printers take a real beating. They're used by a lot of newcomers.
Right.
That's why they're here. And so we learned originally the extruder had a 3D printed gearbox.
Right.
And I can show you one here.
Oh yeah, there it is.
It had planetary gears.
Yep.
But this 3D printer has a 0.4 mil nozzle on it, and it takes quite a bit of force to push the plastic through that. So we were damaging the gears all the time.
Right.
So that's been replaced with a metal gearbox.
Yep.
Purely because of the hammering it gets. Yeah. So,
Terrific.
And unfortunately, they're being used to do much more than 3D printers these days.
Yeah, exactly.
So,
And what have we got on this bench? We've got, looks like a little robot.
Yep.
What does it do? Tell us all about it.
Well, it's the Raspberry Rover. It's a Raspberry Pi powered robot.
Yep.
Got a microcontroller which controls an LCD screen, a nice little ultrasonic sensor.
Yep.
And there's a nice motor driver board underneath.
Yep.
And a couple of battery packs of DC to DC converter. And that's all hooked up to the Raspberry Pi.
Okay, it's only a two-wheeled job, and it just and the back ones are just the chairs off a.
It's actually from a mattress. I managed to scrounge
right,
it.
yeah. Nice work. Terrific, and it's working well. Are you still tweaking it?
The power just fell out.
Right,
so.
yeah, but it's all right.
There we go. But it generally works until I come here. Then every time it comes here, it seems to break.
The white coat syndrome works every time. Yes. Good work. And what's down here? Somebody's lashed up something on a breadboard.
Yeah, it's a 3.2-inch
they're
LCD touchscreen.
Doing some Mandelbrots.
Yep. So it actually renders it all.
Oh, okay. Yep. That's a Leaf Labs Maple board.
Yeah, it's a ST Micro Cortex M3 microcontroller.
Right.
And I'm eventually going to make that into a clock.
Excellent. Terrific. Good projects. And that looks fast. Beautiful. Tell us how fast does it go?
It goes 25 k's an hour, but but if you look at the scale of this, it'll probably be equivalent to 500 k's an hour.
Right. Okay. In scale factor. Nice. I like it. Good work. Whew. What else? A whole bunch of junk up on the racks up there.
Yeah, basically we have run workshops. It's good to have extra sets of soldering irons, laptops, Arduino kits and so on, so we can run tutorials for people.
Hey guys, woo, smile, you're on the EEVblog. Rebecca's from Sydney, she's all the way from Sydney.
Robots and dinosaurs.
Robots and Dinosaurs in Sydney, which I still have not visited yet.
Visit. I'm just working on characterising this little LED matrix.
Ah, nice.
Got a bunch of them, so
Yep.
I'd like to figure out how to drive them properly.
Is there circuitry on the back of that? Is it a...
Just some resistance.
Oh, right. Oh, okay, right. It's just a...
Very basic.
So it's a matrix, or is it... No.
Charlie Plext?
They're from LED spotlights or lights.
Right.
But the drivers kept exploding. So.
Oh, nice. Yes, good work. And are you the only girl here?
Looks like I am at the moment. Yes.
Gosh darn it.
We need to work on the gender ratio.
Yes, good work.
When we ran the Maker Fair, we had a much better ratio of families and things, and I think it's offering lots of projects like so it makes a difference.
Yeah. I think getting the laser cutter up and running will help.
Oh yes, we've got a laser cutter over here.
it's
Ta-da.
being refurbished by Luke. So,
We saw that last time in the last video.
Since then, Luke has gone through all the interlocks and the electrics. The other main thing that's happened is we've changed the electronics. We've now got an Arduino-based control board.
Right. Okay.
It's designed by Luke and manufactured by Freetronics for us.
Nice.
And just as we had it all going, the laser tube failed.
Oh, no.
So it was lasing 1 week and then it stopped. So we need to get another laser tube for it.
Are they easy to get?
Well, I think getting one for overseas might be a bit tricky because they're glass, but they're not too expensive. So we'll figure it out and do it. We know we've got friends who've got like a 40 watt, so we might borrow that for testing.
Right.
And that's an 80 watt, so we need to go back to that.
Double. Lots of
catapults for when
nice.
when kids come around. We say, hey, come make a catapult. 3D print a boulder, and then do some soldering. So soldering kits.
Great stuff. This is more the electronics area, I guess.
Indeed.
Excellent. Another remote control. Another RC car. I'm doing some Altera work here.
Indeed.
Excellent. FPGA stuff. Love it. FPGAs or PLDs?
FPGAs.
FPGAs. Which ones?
It's the Cyclone 2.
Cyclone 2. Component cabinets. Woohoo! And the obligatory arcade machine. Nice work. And check it out, folks. Yes, that is a Cray Supercomputer. Tell us about it, Andy.
Oh, that's a Cray XMP22. So in the early 80s, that would have been one of the fastest machines in the world. But these days, your average iPad's probably a bit faster.
And now it's just sitting in a corner in a hackerspace in the garage in Melbourne.
Oh, that's a great piece of furniture.
Exactly. You can sit on it, There you go.
Sit on it, put your gear on it. It's a talking piece.
Brilliant. Is there any goodness in there if we lift up the...
No, well, the power supplies used to be under here.
Right.
And that's an example power supply. That's a 30 amp 5 volt power supply.
Yep. 30 volt 5 amp.
These are the copper bus bars.
Oh, the bus bars, wow.
These are about 1 inch square.
Yeah.
And so these are sat between each of the columns. And so I can't remember how many amps they carry now. It was an awful lot. You could weld with this. And so it's a small fortune in copper.
Right. So they're solid? They aren't tubes? That's actually solid.
Yeah, try picking that up.
Oh, yeah, that's solid. Bloody hell, folks. That is solid.
Yeah, and so this is 1/5 of the machine.
Right, yep.
And we've got a circuit board.
Oh, there we go.
So this is the
PCB from a Cray Supercomputer, folks.
So this is the program counter, and you can see it's a top board, a second board sandwiched underneath that piece of copper, and same again. So this is a double board, and there are the pins in the back plane.
Yep.
And here are the connectors. These are connected to 5 volts and ground on those bus bars that I showed you. So that machine probably consumed around about 200 kilowatts. And so,
200 kilowatts.
And try holding this board.
Holy crap! That weighs a ton.
Yep, board. Each column had about 70 boards.
Wow.
And there was 4 columns in this machine. The total machine had about 24 columns. So a lot of copper. Yep. A lot of aluminium. So
wow.
That's a great.
That is excellent. I like it. What? They're just not. They're customs.
No, they're 16 gate ECL. So,
ECL. Yep. Okay.
So the original Cray was only made out of fundamentally 3 chips.
Yep.
A couple different type of logic chips, and I think it was a 16 gate. Was the SRAM chips, and that was it.
That was it. There's just lots of them, well engineered into the column-based system. So
it's taking these off. So
because they had to do that back then because that's how you interconnected everything for the fastest speed. So
these So in the back was a wire wiring loom, which took about 9. I think it was about 9 months. And these
it was all wire wrap, wasn't it?
Yeah. Well, not even wire wrap. They were basically connectors that these pins fitted into, and then individually wired point to point. So it wasn't wire wrapped. And so what happened was the heat was carried from the chips along the copper.
To the aluminium. Right.
And in the aluminium there's core bars. And so at the bottom there was a liquid freon, and by the time it got to the top it was gas. Went off to the water to be cooled and compressed back in the frame, just like a big refrigerator basically. In fact, the machines are made in Chippewa Falls in Wisconsin. I believe a lot of the metalwork came from it's like dairy farms basically. And a lot of plumbing. So Yeah, great machine, lots of stories.
Brilliant, folks.
The thing we have here is that's actually a circuit board from a Cray 3.
A Cray 3.
So,
Brilliant. And so this is a Cray 1, is it?
XMP. So it's
XMP.
So
Right.
the Cray 1 was built in 1976. This machine's from about 1982.
Right.
And the Cray 3 was from about the mid-90s, 94 thereabouts. But there's only ever one shipped.
Yep. Right.
Yeah, so it's a bit of history.
I love it.
Over here we've got a Raspberry Pi project. Lachlan might be able to talk a bit about.
Oh, Lachlan. Hey, Lachlan.
Yeah,
good
great.
mate. You're on the blog. Tell us
Okay,
about this
so-
door access system, folks.
This is our community project in action. So we've got a number of members here who've worked on a joint project to allow access to the space based on near-field 13 megahertz reader
Yep.
cards. The idea is we're using a Raspberry Pi, an NFC reader, and when we swipe the reader, nothing happens.
Right. White coat syndrome, folks.
Okay. And so, being good belts and braces engineers, we've put in how good's your night vision?
Well, we'll try it. We'll give it a go.
Our emergency reset system.
Oh, yeah, it works. Emergency reset system.
A read switch buried in there to reset the Pi.
Got it.
And then we have to wait 30 seconds and talk more about it.
Just in case it crashes. Brilliant. Because if it crashes, you can't get in, right?
Yeah, that's right. No, you can't until you reset it.
Right,
So it's
okay.
Give it that time and let it reboot.
All right.
There it is going through its reboot process. We've got, you can see a few different people have worked on different parts of it. There's actually, you can sort of see there's a guy who's written a C code on the Raspberry Pi.
Yep.
We've got a near-field reader here, which is out of China, but very similar to the Adafruit near-field reader. We've got a electronics board with a FET and some driving logic for interfacing to other Hackerspace things such as a laser cutter and lathe we might need to hook up for access control down the track. The power management and cabling, of course, which is always present. We run that now. You can see the green light comes on.
Ah, there we go. We got it. We got it.
We've got the door.
It opens. Ta-da!
Yeah, it does work.
Well done. It does work, folks. You just have to reset it, kick it up the bum occasionally.
And once it's off, it's we've still got the safe exit, through the manual
Nice.
thing for emergency use.
Excellent. Thank you very much. And what's through the door?
What's through the door?
It's just a lounge room.
Chill out room.
Chill out room. If it gets too loud outside. Excellent.
Yeah, so we need to do a bit of work here to some more better couches and
Things to do.
Oh, yes.
Oh, things to do. Huge list of things to do. If you want to come down to the Melbourne Hackerspace and help with the to-do list.
Actually, surprisingly, nearly all those things have been done. We just need to
You just need to tick them off.
press the board and do it again, actually.
Well, that's fantastic. Thanks, Andy.
Well, thanks for dropping by.
Keep
It's
it up.
always a pleasure to see you.
No worries.
See us in a year's time and see what progress we've made.
Yeah, or we're in a bigger space again.
Oh, maybe.
Because how many people are you getting here peak? Sure.
Well, we try to manage the numbers, but usually around 30 or so a meeting, and we try to meet as many times through the week to make use of the space. I'd much rather see a number of meetings throughout the week rather than have one meeting of 80 people.
People turn up.
So, but yeah, if we keep going this way, we may need to look for someone else.
Yep. Excellent.
Okay.
Catch you next time, Andy.
Thanks, Dave.
Thanks.
Bye.